Hello everybody, my name is Edgar Cortes Suárez and I'm a PhD student at UNAM, Mexico. I'm going to talk about the host galaxy properties of 47 Type 1 AGNs in MaNGA. MaNGA is one of the three main projects of the Phase 4 of SLA. It uses the integral field spectroscopy technique to explore in detail the internal structure of the 10,000 closest galaxies. Some of the advantages are the high resolution and the wide coverage in wavelength. UNAM is a member of this international project. The integral field spectroscopy technique has been applied in the study of the AGNs. However, the studies have been focused or in the AGN properties or in the host galaxy properties. With the MaNGA data, we can study both regions at the same time. So our first task was to select the main sample. The usual method to find AGNs is with PPT diagrams. Some authors include extra steps like a minimum value of equivalent width of H alpha to avoid other kinds of source like post-AGB emission or shock emission. We focus our search in the Type 1 AGNs. The supermassive black hole properties can be obtained from the broad component properties. However, to make a distinction between AGNs Type 1 and Type 2 can be a difficult task because a stellar component subtraction has to be applied, and this is a degenerate process. So we perform a flux radio method to find AGNs directly of the observed spectrum. This method is an improvement of the one of et al. 2015. We selected a region around H alpha to include blue luminosity AGNs. We choose two intervals, the blue band and the red band, where the broad component has presence, and one for the continuum. So if the flux radio of the broad band against the flux of the continuum is around 1, we associated this value with not at the galaxies. But if the flux radio is higher than 1, then we can have a possible candidate. We apply this method to the MaNGA product launch 7, and this sample consists in more than 4,600 galaxies. In the right figures, I'll show you the distribution values of the flux radius of the two bands against the signal to noise of the continuum. We can notice that we have two populations, the colored ones and the gray ones. The gray ones are associated with no active galaxies because they have a radius around 1. So to separate this population from the possible AGN population, we use a box plot diagram. And I show you how is this box plot for the two bands at the right figures. To establish a limit value, we use the upper limits of the box plot diagram, and to do more restricted our method, we select only the candidates that were above both upper limits. We found 94 candidates, and after a visual inspection, 47 were cataloged as type 1 AGNs. Some advantage of our method is that it covers AGNs mixed with the PPT1 diagrams. In the figure, we can see our sample as blue stars, and a few of them are below the QL lines. To estimate the parameters of the closest region to the supermassive black hole, it was necessary to subtract the host galaxy. But with a small sample, this can be a controlled process. Using two different programs, we can have the best solution. We use a Starlight that performs a stellar synthesis population and QDblend that constructs an AGN PSF and then remove it from the entire data queue. With the emission line spectrum, we feed the emission lines to all the variety of AGNs found. From the ones with iron 2 emission lines, we have some example in the top figures, to the ones with more than one broad components. Some examples are in the middle figures. With the results, we estimate some of the AGN properties, like the volumetric luminosity and the accretion rate. The mass range of the black holes goes from 6.1 to 8.9. That's for the AGN's properties. For the host galaxies, we look for some parameters such as their morphology and stellar masses. The NPL7 sample stellar masses goes from 7.6 to 12.8, or the AGN's host galaxy tend to live in ones with high mass. All the galaxies were processed by GALF. Starship indexes and PA values were obtained just as host galaxies features like arms, bars, rings, shells, etc. We also look the dataset of Marvin from the kinematic maps. We detect signature of center perturbations and the coupling of gas and stars. I'll show you some examples in the right figures. We also look for information for our AGN sample in Fish, Rosette, and Weiss. 31 of our samples have X-ray or radio emission, but only of them, 16 has both emissions. They seem to show a linear relation. We also found that 3 of our samples has radio jets, And I show you how they look in the first survey. With all the information gathered so far, we started to look out for scale relations. We made a correlation matrix for this purpose, observing that there are two groups of correlations, one related to the AGN properties and one related to the host galaxy. This is a preliminary version. So I'll leave you with my results, and that's all. Thank you.